Today's lecture is going to cover section 1.6, other types of equations. And in this section, we're going to cover radical equations and absolute value equations. So up until this point, we've solved linear equations, rational equations, quadratic equations. So the two other types that are going to be in this section are radical equations and absolute value equations. So let's start with radical equations. So it kind of is just what it sounds like. It's an equation that contains a radical expression. So a radical equation is an equation in which the variable occurs in a square root, cube root, or any other higher root. So for the ones that we're going to focus on, it's going to be square root. So we solve radical equations with nth roots by raising both sides of the equation to the nth power. So since we're going to be working with square roots, we want to square both sides of the equation, because to undo the square root of something, right, if we're going to take the square root of something, if we square it, right, we're going to undo that operation. And you'll see once we get to our first example. So here are your steps for solving a radical equation. So if necessary, isolate the radical on one side of the equation. Then we're going to raise both sides of the equation to the nth power to eliminate the isolated nth root. We're going to solve the resulting equation. And if there's sometimes the resulting equation will still contain radicals, and then we'll just repeat steps 1 and 2 again until there's no radicals in the equation. And then, of course, check all proposed solutions in the original equation. So let's look at example 1. A says solve the square root of 3x plus 18 equals x. We want to solve for x, right? That's the goal. But you see you have a square root in there and x is stuck underneath. So the only way we're going to be able to free it, or free that expression that contains the x, right, the 3x plus 18 from underneath the radical, is to square the radical expression, right? But then I have to square the other side of the equation. So what we're going to do is we're going to square both sides of the equation. So by me squaring the square root of 3x plus 18, now all I have is 3x plus 18. And that's equal to x squared. So I got rid of the radical by squaring it. And now we end up with a quadratic, right? You see how I have an x squared, a 3x, and an 18? This is a quadratic, which we did in the previous lecture. How do we solve a quadratic? We have to get it in standard form. So let's set it equal to 0. So what I'm going to do is I'm going to subtract the 3x and the 18 from both sides of the equation to set it equal to 0. So I'm going to have 0 is equal to x squared minus 3x minus 18. Remember how we approached these in the last video? If you could factor, factor. Otherwise, I would go to the quadratic formula. But this is factorable. So look, we're going to have 0 equals. Now I'm going to have two factors, right? What two numbers multiply to negative 18 and add to negative 3? That's going to be a negative 6 and a positive 3, right? Negative 6 times 3 is negative 18, but negative 6 plus 3 is negative 3. Now, just like we did in the last lecture, set each factor equal to 0 and solve. So x minus 6 equals 0, or x plus 3 equals 0. And when we solve, I'm going to get x equals 6, or x equals negative 3. Now we want to check our answers, right? So go back to the original to check. So we have the square root of 3x plus 18 should equal x. Let's check x equals 6 first. So we're going to have the square root of 3 times 6 plus 18 should equal 6. 3 times 6 is 18. 18 plus 18 is 36, and the square root of 36 is 6. Now let's check x equals -3. So if we check x equals -3, and we go to plug in, we're going to have 3 times -3 plus 18 equals x, which is -3. But I'm already seeing a problem because how can I take the square root of something and get a negative number, right? But let's say we didn't realize that. Let's go along with this. Look, 3 times -3 is -9. -9 plus 18 is equal to 9. And the square root of 9 is 3, not -3. So we have to reject that solution. So my answer or my solution is that x is equal to 6. So let's look at the next one. For part B, we want to solve the square root of x plus 3 is equal to x. So very similar situation to A, where we have a radical, x is stuck underneath the radical, so we're going to have to do something about that, right? But the first thing you always want to do is isolate the radical term. You see how the radical term is not by itself on the left. We have this constant here. So I'm going to bring that 3 to the other side by subtraction. So I'm going to have the square root of x plus 3 is equal to x minus 3. Now I have the radical isolated. Now we can square both sides, right? Because I want to get rid of the radical. So I'm going to square both sides. So on the left, I'm going to have x plus 3 is equal to, on the right, x minus 3 squared, which is just x minus 3 times x minus 3, right? So now we want to solve for x. We got rid of the radical. Let's expand the right-hand side, right? We have x plus 3 is equal to, let's do FOIL. So x squared minus 3x minus 3x plus 9. So we're going to get x plus 3 equals x squared minus 6x plus 9. And we have an equation. We want to solve for x, but we have a quadratic equation, right? I see that x squared term in there. Let's get it in standard form. Let's set the left-hand side equal to 0. So I'm going to subtract x and subtract 3 from both sides. Get it in standard form. So I'm going to have 0 is equal to x squared minus 7x plus 6. Let's try and factor, right? Anytime we want to solve a quadratic, my first attempt would be to factor. So we're going to have 0 equals now think of two factors, right? X plus or minus something times x plus or minus something. Well, what are those two somethings? What two numbers multiply to 6 but add up to -7? So that's going to be a -1 and a -6. And I'm just gonna rewrite this a little closer. So x minus 1 times x minus 6, right? Because a negative times a negative is a positive, and a -1 plus a -6 is -7. So let's set each factor equal to 0. So we're going to have x minus 1 equals 0 or x minus 6 equals 0. So we're going to have x equals 1 or x equals 6. And let's check our answers. And I'm just going to go to the whiteboard to check, just because I have more room over there. So let me just rewrite the equation. So we have the square root of x plus 3 should equal x, and we got x equals 1 or x equals 6. So let's go to the whiteboard and check our answers. Okay, so the original was square root of x plus 3. Hold on. So we have the square root of x plus 3 plus 3 equals x. So if we check x equals 1, we're going to have the square root of 1 plus 3 should equal x, which we're saying is 1. So we're going to get the square root of 4 plus 3 is equal to 1. Square root of 4 is 2. 2 plus 3 is 5, not 1. So that doesn't check out. Now let's check x equals 6. So we're going to have the square root of 6 plus 3 should give us x, which is 6. 6 plus 3 is 9. Square root of 9 plus 3, does that give us 6? Square root of 9 is 3. 3 plus 3 is 6. So x equals 6 is my only solution. So we have to reject x equals 1. So my solution is x equals 6. Let's do one more. So this one contains 2 radicals, but we're going to treat it the same way as the other ones. We're still going to isolate one of the radicals, get rid of the radical sign, but then we might have to repeat those steps if I still have a radical expression remaining. So let's look at this one. So see how I have 2 radical expressions here in this equation? I'm going to isolate the one all the way to the left. Let's get it by itself. So if I add the square root of x plus 4 to both sides, then I'm going to have the square root of 3x plus 1 equals 1 plus the square root of x plus 4. So all I did was isolate one of the radical terms, since, we can't get rid of them both at the same time. So let's start with 1. So to get rid of the radical, right, that we just isolated, let's get rid of the radical term. So we're going to square it. But then we have to square the other side of the equation as well. Whatever we do to one side, we have to do to the other side. So square root of 3x plus 1 squared is 3x plus 1. And now I'm going to have 1 plus the square root of x plus 4 times 1 plus the square root of x plus 4, right? Because we're squaring it. So let's FOIL. So I'm going to have 3x plus 1 is equal to, if I do first terms, 1 times 1 is 1. Now, if I do outer, I'm going to have 1 times the square root of x plus 4, which is the square root of x plus 4. If I multiply my inner terms, square root of x plus 4 times 1, I'm going to have another square root of x plus 4. And now multiply the last terms. And the square, it's going to be the square root of x plus 4 times the square root of x plus 4. And we could simplify that in the next step. So look, we can combine those two terms that I just underlined in red, right? So we're going to have 3x plus 1 equals 1 plus 2 times the square root of x plus 4, right? Because there's two of them. And then plus the square root of x plus 4 times the square root of x plus 4 is just x plus 4. So now you see how we have another radical term still on the right-hand side. We're left with that square root of x plus 4. So let's isolate it. Get rid of everybody else. So I could combine like this positive 1 and this 4 is 5. So I really have 3x plus 1 equals 1 plus 4 is 5. And then we have plus the x plus the 2 times radical x plus 4. So I'm going to gather the non-radical terms to the left-hand side. So I'm going to subtract 5 and I'm going to subtract x from both sides. So 3x minus 1x is going to be 2x. 1 minus 5 is minus 4. And that's going to equal 2 times the square root of x plus 4. So we want to isolate the radical, right? We want to get the square root of x plus 4 by itself so we could square it. But there 2 in front's a problem, right? And it's attached by multiplication. So if I divide by 2, then it's gone, right? But I have to divide everybody by 2 on the left-hand side as well. So 2x over 2 is x, minus 4 divided by 2 is 2, and that's going to equal the square root of x plus 4. Now I'm ready to square my radical, but then I have to square the left-hand side as well. So I'm going to have x minus 2 times x minus 2 on the left equals x plus 4. We got rid of the radical. If I FOIL x minus 2 times x minus 2, right, if I do my distributive property, I'm going to have x squared minus 2x, but then minus another 2x, which is minus 4x, and then negative 2 times negative 2 is positive 4. So x squared minus 4x plus 4 is equal to x plus 4. Now I have no more radical terms. I'm ready to solve for x, and it's a quadratic equation again. You see your x squared term? So gather all your terms to the left and set the quadratic equal to 0. So I'm going to subtract x and subtract 4 from both sides. So we're going to have x squared Now negative 4x minus x is going to be minus 5x. That positive 4 and negative 4 is 0. And we're going to be setting equal to 0. So we have x squared minus 5x is equal to 0. And I'll continue this on another slide. So we have x squared minus 5x is equal to 0. So we have to solve that. So let me just hop over to the whiteboard. So we want to solve x squared minus 5x is equal to 0. So remember how we should approach every quadratic. Try to factor. And I can factor the left-hand side, right? I could factor out an x. So if I factor out an x, I'm going to be left with x minus 5 as my other factor. So x times x minus 5 is 0. Now set each factor equal to 0, just like we've been doing. So either x equals 0 or x minus 5 equals 0. So we have x equals 0, or if I solve the equation on the right, I'm going to get x is equal to 5. So we're getting either x equals 0 or x equals 5. And now let's check, right? So the original, always go back to the original to check your answer. So the original is the square root of 3x plus 1 minus the square root of x plus 4, and that should equal 1. So all I'm doing is going back to the original, which I just highlighted in green, and we're going to check our answer. So let's go back to the whiteboard. So we have the square root of 3x plus 1 minus the square root of x plus 4 equals 1. So first, let's check x equals 0. So we would have the square root of 3 times 0 is 0, right? And then plus 1, so square root of 1 minus the square root of 0 plus 4, because I'm plugging in 0, which is 4. That should give us 1. Square root of 1 is 1. Square root of 4 is 2. So we have 1 minus 2, which is negative 1, which does not equal positive 1, right? So x equals 0 does not check out. Now let's check x equals 5. So the square root of 3 times 5 plus 1 minus the square root of 5 plus 4 should give us 1. 3 times 5 is 15. 15 plus 1 is 16. So we have the square root of 16 minus square root of 5 plus 4, which is 9. Square root of 16 is 4. Square root of 9 is 3. 4 minus 3 is 1, and that checks out. So in this case, we have to reject 0, right? And we're going to go with x equals 5. So my solution is x equals 5. Very, very important that we always check our answers. Okay, so let's go back to the worksheet. So those were some examples of how we solve radical equations. The key is isolate the radical, get rid of the radical. If it's a square root, we square both sides, and then we take it from there. The other type of equation that I said we're going to be solving in this section is absolute value. Remember what absolute value is. It describes the distance of x from 0 on a number line. So it's just distance. So I think the easiest way to think about it is like this. I'm going to give you an example on the whiteboard, and then we'll go back to the worksheet. So what if I said to solve the absolute value of x equals 2? So remember, absolute value means distance. So whatever we take the absolute value of, whatever's inside the absolute value, we want the distance from 0 to be equal to 2. So imagine this on a number line. Here's 0, 1, 2, 3, 4. Here's -1, -2, -3, -4, and so on and so forth. The absolute value of what number is going to be 2, in other words? What is going to be a distance of 2 from 0? Well, here's 0, right? If I go 2, that's positive 2. But if I go backwards 2, that's -2. So both 2 and -2 satisfy this equation, right? Because the absolute value of -2 is 2, right? Because that's the distance from 0 on the number line. And the absolute value of 2 is also 2. It's the same distance. So whenever we're solving absolute value, in general, if the absolute value of x is equal to some constant c, then what we just realized is that x is going to be equal to c, but also -c, right? Because in the case that we just looked at, my answer was 2 and -2. So whenever we have the absolute value of x is equal to c, some constant, then x is equal to -c or x is equal to +c. Because there's two ways we could go from 0, right? In the positive direction or the negative direction. And I have this definition in the notes on the worksheet here. Instead of absolute value of x, the book is using absolute value of u. So if the absolute value of u is equal to c, then either u is equal to +c or u is equal to -c. So let's look at an example. Let's look at A for example 2. Absolute value of x is equal to 6. So take x, whatever's inside of the absolute value, and set it equal to c, which is 6 in this case, or x could be equal to -c, which would be -6. And it makes sense because on a number line, both 6 and -6 are a distance of 6 from 0 on the number line. So my two solutions are either x is equal to 6 or x could be equal to -6. So let's look at the next one. So the absolute value of 2x minus 1 is equal to 5. We're going to do this the same way. So set whatever is inside the absolute value, like in this case, 2x minus 1. So either 2x minus 1 is equal to c, or 5 in this case, or 2x minus 1 is equal to -c, or -5. So we have to set it equal to both the positive and the negative version of c, and then solve. So if I solve the first one, if I add 1 to both sides, I'm going to have 2x is equal to 6. Divide both sides by 2, right? So I'm going to get x is equal to 3. Or now solve the other equation. if I add 1 to both sides, I'm going to get 2x equals negative 5 plus 1 is negative 4. And then x would be equal to negative 4 divided by 2, which is negative 2. So we have x equals 3 or x equals negative 2. And of course, check your answers, right? Plug in 3 to the original. If I were to plug in 3 to the original, 2 times 3 is 6. 6 minus 1 is 5. And the absolute value of 5 is 5. If we plug in negative 2 for x, 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. And the absolute value of negative 5 is 5. So they both check out. So again, always important to check your answers. Go back to the original. For C, we have the absolute value of x minus 2 is equal to 7. So set the expression that's inside the absolute value equal to 7 and negative 7. So we're going to have x minus 2 equals 7, or x minus 2 equals negative 7. And then we could solve, right? So on the top one, add 2 to both sides. We're going to get x is equal to 9. Or solve x minus 2 equals negative 7. Add 2 to both sides. And we're going to get x equals negative 5. And when you go and check both back into the original, they're both going to check out. So we have two solutions, x equals 9 and x equals negative 5. Let's do one more just to make sure we're comfortable. So D, we have 5 times the absolute value of 1 minus 4x minus 15 equals 0. Now, in order to solve, we need to isolate the absolute value expression. We didn't have to in the other ones because it was already isolated on one side. So we need to isolate the absolute value of 1 minus 4x. So the first thing I'm going to do is add 15 to both sides. So I'm going to have 5 times 1 minus 4x, right? The absolute value of 1 minus 4x equals 15. And remember, we're trying to isolate the absolute value. So I'm going to divide both sides by 5. So I'm going to get the absolute value of 1 minus 4x equals 15 divided by 5 is 3. So we have the absolute value of 1 minus 4x is equal to 3. Now we're in that standard form, right? Absolute value of u is equal to c. So now we could set u, or in this case, 1 minus 4x equal to 3 or negative 3, right? So, or we could set 1 minus 4x equal to negative c, or negative 3. And now we could solve both equations. So here on the left, I'm going to subtract 1 from both sides. So I'm going to get negative 4x equals 2. And now divide by negative 4. Divide both sides by negative 4. So I'm going to get x equals negative a half, right? 2 over 4, but it's negative. Or over here, if I subtract 1 from both sides, I'm going to get negative 4x equals negative 4. divide by -4. And we're going to get x is equal to +1. So let me circle these in red. So we have x is equal to 1 and x is equal to -1/2. And if you check both your answers, you're going to see that they check out. So if you were to go back and plug in -1/2 to the original and x equals 1 to the original, they're both going to check. So the last thing that I have before we wrap up this lecture are just 2 application questions. So anytime I say application questions, the word problems, right? Kind of using what we've learned, but now in a realistic model. So let's look at example 3. So we're given the formula h equals -2.3 times the square root of I plus 67.6. This models the weekly television viewing time h in hours by annual income I in thousands of dollars. So what annual income corresponds to 33.1 hours per week watching TV? So let's highlight what we know. So we're given a formula, right? H is equal to the following formula, which contains a radical, right? So I know, okay, we're working with a radical equation and we just solved those above. And in this relationship, H stands for hours that we watch TV per week. And I stands for annual income, and we're in thousands of dollars. So the question is, what annual income corresponds to 33.1 hours per week watching TV? So we're looking for an income. So we're solving for I, right? I is the question mark, and we know that the number of hours, which is H, that we watch TV per week is 33.1. So we were given a value for H, and we're being asked to solve for I. And we know H is equal to -2.3 times the square root of I plus 67.6. H is 33.1, so I'm going to replace H with 33.1, so that's equal to -2.3 times the square root of I plus 67.6. Now we just have to solve for I, and we know how to do this, right? We did it above when we started this lecture, we were solving radical equations. So the first thing is isolate the radical, right? Let's isolate the square root of I. So the first thing to go is the 67.6 by subtraction. So 33.1 minus 67.6 is going to be -34.5. And that's going to equal -2.3 times the square root of I. So let's continue over here. So I have -34.5 equals -2.3 times the square root of I. Now we want to get the square root expression alone, isolated, right? So what I'm going to do is let's divide by -2.3. So -34.5 divided by -2.3 is going to be 15. So 15 is going to be equal to the square root of I. Now I is isolated, right? Now the square root of I is isolated. I have my radical term isolated. So now I need to solve for I, right? How do I get rid of that radical? Well, what were we doing earlier in the lecture? We were squaring, right? Because if I'm taking the square root of I, if I raise it to that same index of 2, right, then I'm just going to end up with I. But then I have to square the left-hand side, right? 15 squared is going to be 225. So I is equal to 225, but what are the units, right? Now, when we're solving an application question, we have to think of it in terms of units. And I stands for income. And it says right here, we're in thousands of dollars. So I is going to be equal to $225,000. So we're in thousands. And let's look at one more example. So example 4 says an engine manufacturer produces piston rings that are supposed to have an ideal diameter of 150 millimeters. However, due to the nature of the machinery, there's an acceptable margin of error or tolerance. For a ring to pass quality control, its diameter could be no more than 0.05 millimeters different from the ideal diameter. And we were given the equation to represent this. So the absolute value of D minus 150 equal to 0.05 is that equation, where D is the actual diameter of the piston ring. So the question is, and let's highlight the question, what is the maximum and minimum acceptable diameter for the piston rings? So we're trying to solve for D, right? Diameter is D. And it says it right here. D is the actual diameter of the piston ring. So if we know that the absolute value of D minus 150 is equal to 0.05, we could solve for D, right? We were just doing that above when we were solving the absolute value equations. Remember, the trick with the absolute value equations is take what's inside the expression inside the absolute value and set it equal to C and negative C, where C in this case is 0.05, right? That's the constant that this absolute value expression is equal to. So we're going to have D minus 150 is equal to positive C or D minus 150 is equal to negative C or negative 0.05. So solve the one on the left. So when we solve for the one on the left, we're going to get D is equal to 150.05, and we're in millimeters. Or on the right-hand side now, when I add 150 to both sides. So now we're taking a negative 0.05 and we're adding 150, and we're going to get D is equal to, and let me just go back to blue to keep it consistent. $149.95 millimeters. So the minimum acceptable diameter is going to be the 149.95 millimeters, that's the smaller one, right? And then the maximum acceptable diameter is going to be the bigger one, the 150.05 millimeters. So that would be the maximum and minimum acceptable diameter for the piston rings based on that equation. And that wraps up section 1.6.